Hey there. Tonight, you're lying back beneath the sky. Maybe on your bed, maybe just in your imagination. But either way, the ceiling above you has disappeared. The world is quiet. The room fades, and above you, stars, a vast black canvas, speckled with cold burning points of light. You're no longer inside a room. You're inside the cosmos. And you're wondering something very simple, very ancient. How big is all of this really? Not in kilometers, not in light years, but in the kind of size that stretches your thoughts until they melt into silence. Before we go too far, let's do the one thing we always do around here, because this will be a ride. So before you get comfortable, take a moment to like and subscribe to the video, but only if you really enjoy what I'm doing here. And if you feel like sharing your local time and where you're watching from. I love seeing how far this little sleepy universe reaches. Now dim the lights. Maybe turn on a fan for that soft background hum. And let's start our journey together. Tonight. So, you're lying there, and above you is everything. And the question begins to expand, just like the thing you're asking about. What do we even mean when we say the universe? Is it just stars? Galaxies? What about the dark matter, the energy, the space between the space? The deeper you think about it, the more the edges fray. It's like asking how big a dream is. Depends on how deeply you're dreaming. For most of human history, we imagined the stars as just distant lights stuck to a kind of celestial wallpaper. People thought maybe the sky was a dome, that beyond it was heaven or fire or the gods. And for most purposes, that was enough. You didn't need a number. You needed mystery. But mystery didn't satisfy everyone. Eventually, people started to measure. Not just where stars were, but how far. They used angles, shadows, eclipses. Some estimates were wildly wrong, others were uncannily close. Even the ancient Greeks, with no telescopes, guessed the moon's distance with eerie accuracy using just geometry and curiosity. The real mind-bending began when we realized that stars weren't nearby dots, but other suns. Entire burning worlds, scattered through the night. Suddenly, the scale exploded. Not one sky with pinholes, but billions of stars, each one potentially with planets, with moons, with life. And all of them at incomprehensible distances. But wait, it gets worse. Or better, depending on how much you enjoy feeling small. Because it's not just that there are a lot of stars. It's that space itself is stretching. The distances between. Galaxies are growing, not because they're flying apart, but because the space between them is growing. Like raisins in rising dough. If you were one raisin, you'd think the others were zooming away. But they're not moving, you are. Or more accurately, the dough is. And that's where things really start to slip. Because if the universe is expanding, then it must have started smaller. And if it's getting bigger, well, how big is it now? You might want to say, the universe is insert number light years across. But the problem is, we don't know. If it has an across, it might be infinite. Or it might be finite, but unbounded like the surface of a balloon. You can walk in one direction forever and never find an edge. You'll just loop around. That idea makes your pillow feel a little softer, doesn't it? Here's something mainstream to ground us. The observable universe, the part we can actually see, is about 93 billion light years across. That's right. Even though the universe is only 13.8 billion years old, we can see much farther than 13.8 billion light years. Why? Because space has expanded while the light was traveling. So those ancient photons left galaxies that were closer then, but are much farther away now. It's cosmic lag. And here's something fringe to fall asleep to. Some cosmologists have suggested that the universe may be infinitely large. That beyond the limits of what we can see, it just keeps going and repeating. There could be another version of you out there. Not a metaphorical you, but a literal arrangement of atoms just like yours. Because with infinite space and finite variations, duplicates are inevitable. Still, some argue the opposite, that the universe may have a curved geometry that brings it back around on itself. That if you traveled far enough, you'd return to where you began not through a wormhole, but by simply moving forward. And that's where we'll start tonight. Floating on your bed, breathing slowly as the stars blink quietly above. The journey has begun. You're not just looking up at the sky anymore. You're looking into something that may not end. Welcome to Infinity, Explorer. Now that your mind is drifting just slightly off its axis, let's ease deeper into the question. How exactly do you measure something that might be immeasurable? If the universe is constantly expanding, and if it might not even have an edge, then what are scientists doing when they say size of the universe? Measuring what, exactly? To understand this, we have to go on a little journey not across galaxies, but across time. Picture yourself walking through a dusty old library. Books everywhere, ancient scrolls and cracked globes. And in the back, you find a shelf with some of the most earnest attempts humanity has ever made to pin down the infinite. Star charts, models of planetary motion, scribbled formulas from long-dead astronomers with excellent beards. The story of measuring the universe begins with the night sky, but very quickly spills into physics, philosophy, and something surprisingly intimate. Light, because light isn't just how we see the universe. It's how we measure it. Let's start with the idea of a light-year unit of distance, based on how far light travels in a year. That's about 9.46 trillion kilometers, or nearly 6 trillion miles. It sounds absurd, and it is. But in cosmic terms, it's kind of small. Our own Milky Way galaxy is about 100,000 light-years across, and that's just one of an estimated 2 trillion galaxies in the observable universe. Now, ancient astronomers didn't have light years, but they did have cleverness. Using parallax, the apparent shift of a nearby star against the background of more distant stars as Earth orbits the Sun, they could measure stellar distances with just math and careful observation. It was like a cosmic triangle, with your eye at one point, Earth's orbit forming the base, and the star forming the apex. Fast forward a few centuries, and we're bouncing radio waves off the moon, tracking star movements with satellite precision, and watching light curve ever so slightly as it passes near massive objects. Thanks, Einstein. You see, light travels at a constant speed, about 299,792 kilometers per second. That's not just a cosmic speed limit, it's the ruler we use to measure everything else. The farther away something is, the longer its light has taken to reach us. When you look at a star that's 500 light years away, you're seeing it as it was 500 years ago. You're literally looking into the past. Every glance at the sky is a little time machine. This gives us a kind of map, a glowing fossil record of how things used to be. We're not seeing galaxies as they are now, but as they were when their light began the journey. In a sense, we'll never know what those galaxies look like today, and we'll never see new ones beyond a certain point, because their light will never reach us. They're too far, and space is expanding faster than light can travel. That's the next wrinkle in our mental blanket. As the universe expands, it doesn't just carry galaxies away from each other, it stretches the very light they emit. This is called redshift, and it's like the cosmic version of a stretched-out violin string. The farther away a galaxy is, the more its light is shifted toward the red end of the spectrum. It's a Doppler effect, but for light instead of sound. By measuring how redshifted a galaxy's light is, scientists can calculate how fast it's moving away, and thus how far it must be. It's like looking at a balloon with dots drawn on it. As the balloon inflates, the dots get farther apart, not because they're moving on the surface, But because the surface itself is stretching dot, so when scientists say the observable universe is 93 billion light years across, that doesn't mean we've traveled that far. It means that's how far light has traveled, while the space it moves through has been stretching. The light from those distant galaxies started its journey billions of years ago when they were much closer. But space has been inflating around it like taffy in slow motion. And here's your academic twist. Cosmologists still debate whether the universe is infinite, finite, but boundless, or something stranger still like a projection, or a holographic surface encoded with lower dimensional data. We'll dip into that madness later. Now, let's sprinkle in something deliciously weird. In 2003, a group of scientists used the Sloan Digital Sky survey to look for patterns in the large-scale structure of the universe. And some thought they detected repeating motifs, almost like a cosmic fingerprint. The implications? Maybe the universe isn't infinite. Maybe it's wrapped in on itself. Or maybe it's a loop. Pause. Breathe. Remember, this is the kind of scale where human intuition starts to melt. You can't picture billions of light years. Not really. But you can picture this. A photon, just one leaving a galaxy on the edge of the visible cosmos, traveling for 13 billion years, dodging stars, passing clouds of gas, slipping past black holes until it finally ends up here, on your eye. Tonight, that's what you're made of. That's what you're inside of. Light that's older than anything you know, arriving like a whispered message from a past so ancient, it's basically magic dot. So when you hear the word universe, remember, we're not talking about something you can hold in your head. We're talking about something that holds your head inside it, and you haven't even left your bed yet. You're floating now, not just through space, but through ideas that bend and stretch like constellations in your mind. So let's keep unraveling the thread. If the universe is so big and so ancient, and the light takes so long to get to, is there a limit to what we can ever see? Is there a cosmic curtain that keeps the rest hidden? Yes, and it's called the cosmic horizon, the edge of the observable universe. It's not a physical wall. It's not a border with signs saying, "End of universe, turn back now." It's simply the furthest distance from which light has had enough time to reach us since the beginning of time. Anything beyond that horizon? It might exist. It might be teeming with stars, galaxies, entire alien civilizations. But we'll never see it. The light hasn't had enough time to get here, and it never will. Imagine being in a vast, foggy meadow. At dawn, you can only see as far as the light travels before it fades into mist. That doesn't mean there's nothing out there. It just means you can't know. That's the cosmic horizon. A fog made not of weather, but of time and light. And here's the eerie twist. That horizon is always changing. As time moves forward, light from farther away has time to reach us. The horizon expands. But simultaneously, the expansion of space is pulling other galaxies out of reach. It's a race between light and distance, and in many cases, distance is winning. Here's a mainstream fact to float on. Right now, the expansion of the universe is accelerating. Thanks to something we call dark energy, distant galaxies are speeding away from us faster and faster. That means more and more of the universe is slipping beyond the cosmic horizon. We can still see some of that ancient light, but we'll never see what happens next in those galaxies. They're already too far. And the weirdest part? We're not moving. The galaxies aren't actually zooming through space like little cars on a track. Instead, space itself is expanding, carrying them farther apart. It's like drawing galaxies on a balloon and blowing it up. The ink doesn't move, but the surface stretches. This leads to a spooky implication. If you wait long enough, the night sky will go dark. In a distant future billions of years from now, most galaxies will have redshifted so far away that their light will no longer be visible. Our descendants, if they're still around, will look up and see only a lonely, empty sky. They won't. No, there were once trillions of galaxies dancing in the distance. Imagine how lonely that would feel, Dot. So back to our question. How big is the universe really? Well, we've only been talking about the observable part, the part we can see. But beyond that, no one knows. Maybe it's infinite. Maybe it loops. Maybe it's embedded in a higher dimensional shape we can't even imagine, like the 3D surface of a 4D hypersphere. Here's an academic curveball. Some physicists speculate that the universe could be finite but unbounded. That means it has no edge, but it still doesn't go on forever. A popular metaphor is the surface of the Earth. You can walk in a straight line forever, and eventually end up where you started. There's no edge, but it's still finite. Now, imagine that in 3 dimensions. You'd be flying in a straight line through space, only to eventually loop around without ever hitting a wall. That's a universe without borders, Dot. And now for your fringe treat. There's a hypothesis called conformal cyclic cosmology, proposed by physicist Roger Penrose. It suggests that the universe doesn't just expand forever, it eventually becomes so stretched out that time and space flatten, and then reboots. A new Big Bang, a new universe. Not in a parallel reality, but in a kind of cosmic reincarnation. The death of one universe becomes the birth of the next, Dot. So now you're lying there, and the universe around you isn't just vast. It's layered. It's shaped by light, warped by gravity, stretched by time, and filled with riddles that science hasn't yet solved. It might be infinite, or cyclical, or a simulation on a cosmic hard drive running in a higher dimension. Let's not go there, yet you're still digesting the balloon metaphor. But here's the gentle truth. No one knows. Not for sure. The universe might be bigger than any number we can write, bigger than any metaphor we can invent. It might be unknowable, and yet you're in it. You're made of it. The atoms in your fingers came from stars that exploded billions of years ago, and the photons that hit your skin at sunrise may have been dancing across space for centuries. That's the real magic. You're not separate from the universe you're trying to measure. You're inside it, of it. And your brain, this squishy electric cloud of cells, is quietly trying to understand the shape of everything, Dot. So how big is the universe? Big enough to contain the question, and small enough that the answer is already humming through you. So, let's stretch our imagination even further. We've tiptoed to the edge of the observable universe. We've imagined galaxies sliding out of sight like ships on an endless ocean. But what lies between all that glowing matter? Between the galaxies? Between the stars? The answer is almost nothing. And somehow, that nothingness is just as important. Most of the universe, more than 99.9999% of it, is empty space. But this isn't the comforting kind of emptiness, like a quiet room or an open field. This is vacuum, a place where not even a single atom might exist for miles or even light years. It's the kind of nothingness that could swallow sound whole, that wouldn't flinch if a planet floated through it. And yet this nothingness is teeming with weirdness. Quantum weirdness, to be specific, even in the darkest, most desolate corners of space, particles are constantly appearing and disappearing. Little blips of energy wink into existence and vanish again in a heartbeat. These are quantum fluctuations, and they might be the ghostly breath of the universe, itself tiny reminders that even nothing is never truly empty. Here's a solid, mainstream science fact. Physicists have confirmed that even in a perfect vacuum, energy exists. It's called the zero-point energy of space. It's the lowest possible energy state, not absolute nothingness, but a shimmering hum that can never be fully silenced. Some have suggested this is where dark energy comes, from the mysterious force that's making the universe expand faster and faster. The very fabric of space might have energy, simply because it is. Now, here's a fringe why. Brain tickler. Some scientists believe that quantum fluctuations in empty space could eventually spawn entire universes. That's right. Just as particles blink into and out of existence, it's been proposed that entire cosmic bubbles could emerge, tiny universes splitting off from ours, like soap bubbles in a cosmic bath. Each one could have different physics, different time, different versions of reality. Ours is just one. Back to you, cozy under your blanket. You're lying in a world that's spinning through this great vacuum. Earth itself is flying through space at around 30 kilometers per second around the sun, which itself orbits the center of our galaxy at about 220 kilometers per second. And the galaxy? It's speeding through the universe at thousands of kilometers per second, headed toward ... something. Or maybe away from something else. You don't feel it, of course. But it's happening. And all around us, that inky vacuum hums with potential. The light from stars passes through it, bending and stretching. Cosmic rays shoot through it, sometimes smacking into our atmosphere and causing little particle fireworks. Gravity waves ripple through it, carrying messages from colliding black holes that happened billions of years ago. And here's something poetic to consider. Even in the emptiest places, light still travels. It crosses this dark sea without slowing down, never tiring, never stopping. It races along at exactly 299,792,458 meters per second, unfazed by the silence. That speed, constant, universal, and unchanging, is like the heartbeat of reality. It doesn't matter if the light is from a match or a supernova. It moves the same. Always. But why? Why is the speed of light the way it is? Why not faster? Why not slower? We'll explore that soon. But for now, just know this. The vacuum of space, the nothingness, is not empty. It is alive with laws and forces, energy and potential. It holds the stars in place and cradles every breath of light that has ever existed. And you, tucked into your little spot in the cosmos, are moving through it. Wrapped in a thin layer of atmosphere, perched on a rocky ball, hurtling through a sea of silence, looking out at the stars, and wondering about everything. So maybe the universe isn't mostly emptiness after all. Maybe it's mostly mystery. And just maybe, that mystery is what keeps us reaching. Let's take a moment to return to a simple, unsettling question. If the universe is expanding, what is it expanding into? You'd think it's a straightforward question, right? Space is getting bigger, so it must be growing into something. Maybe a larger void, maybe some kind of superspace beyond our universe. But here's where things get strange. According to the best physics we have, space isn't expanding into anything. The expansion is of space itself. There is no outside. The universe isn't pushing into emptiness. It's just getting roomier inside. Imagine baking raisin bread. As the dough rises, the raisins move farther apart, not because they're moving through the dough, but because the dough itself is stretching. Now picture the raisins as galaxies, and the dough is space. That's the idea. Only ... There's no oven, no kitchen, no bakery. Just dough. Everywhere. Now, you might be asking, how big is it all now? That's where we get tangled in definitions. The observable universe, the part we can see, because its light has had time to reach us, is about 93 billion light-years across. Remember, that's just what we can observe, not necessarily all there is. The universe may be much larger, even infinite. The reason it's larger than 27.6 billion light-years, 13.8 each way, is because space itself has been stretching while the light was on its journey toward us. Light left ancient galaxies billions of years ago, And in that time, space pulled them even farther away. So we might only be seeing a small patch of a much bigger quilt. Some scientists believe the whole thing might be infinite, with galaxies going on forever. Others think it loops back on itself, like a four-dimensional donut where traveling far enough in one direction might bring you back to where you started. The problem is, we can't test this, at least. Not yet. Here's your mainstream science fact. In 2020, researchers using the Planck satellite data reaffirmed that the universe is remarkably flat, not curved, like a sphere or saddle. This suggests that if it's not infinite, it's at least really big, like, can't even write it down kind of big. And here's your weird fringe idea. Some cosmologists propose that our universe is one bubble in a sea of many, part of a multiverse, where other universes are constantly inflating, budding off from cosmic inflation like bubbles in boiling water. These other universes might have different physical laws, or even different dimensions of time. Ours just happens to be one that supports life, or dreams, or podcasts about how weird it all is. So where does this leave you, the dreamer under the blanket? You are not on the outside of anything. You're in the middle of everything. No matter where you stand, space stretches away from you equally in all directions. You are always at the center of your observable universe, which means everyone is. You could be in Istanbul or Iceland, or inside a mountain cabin with nothing but a cup of tea and a fuzzy blanket, and you're still the middle of it all. That's not ego, it's just geometry. And as the universe expands, the stuff in it gets farther apart. Stars fade. Galaxies slip away. Eventually, in a far, far future, the night sky could go dark, not because the stars went out, but because their light can't reach us anymore. But don't worry. That's trillions of years from now. For tonight, the stars are still there. The light from galaxies is still arriving. The universe is still whispering its secrets. And you lucky little cluster of stardust and consciousness are here to listen. So stretch out. Let the cosmos stretch with you. And remember, you're not floating in the universe. You are the universe, thinking about itself. Let's go deeper into numbers that try to describe. Something bigger than numbers should be allowed to touch. We've talked about how vast the observable universe is. But what about the number of things inside it? Let's do a quiet count. Shall we? Whispered estimates only, no calculators needed. Scientists believe there are around 2 trillion galaxies in the observable universe. Trillion, with a T. Each of those galaxies contains hundreds of billions of stars. That means we're looking at a few hundred sextillion stars. Yes, that's a real number each, potentially with planets, moons, dust rings, comets, and maybe, just maybe, a few cozy aliens with their own sleepy podcasts. Now, take a breath. Because even those mind-melting numbers only apply to the part of the universe we can see. The rest? Unmeasured. Possibly unreachable. Possibly infinite. But here's the real kicker. The deeper into space we look, the further back in time we see. That's because light doesn't arrive instantly. It travels. So when you gaze into the night sky, you're not seeing stars as they are. You're seeing them as they were. Some of those twinkles are from stars that no longer exist. Their light is the last echo. Their goodbye. Astronomers call this concept look-back time. The farther away a galaxy is, the older the image we receive. It's like cosmic archaeology. By photon. With every step deeper into the universe, we're peeling back another layer of time itself. Here's a mainstream scientific gem. The James Webb Space Telescope, launched in late 2021, has been peering into galaxies more than 13.4 billion light-years away. That's light that left its source just a few 100 million years after the Big Bang. We're watching baby galaxies wobble through their first steps. The universe was barely out of diapers. Now, here's a fringe theory for your pillow. Some researchers have proposed that our whole universe might be a hologram, a 3D illusion created from information encoded on a distant two-dimensional surface. Imagine your whole life, your room, your cat, your tea, everything being projected like a cosmic movie from the edge of reality. No, it doesn't mean you're fake. It means reality is weirder than we thought, and possibly cleverer. There's a reason physicists often sound like poets with chalkboards. The numbers are too big, the space is too wide, at times too deep. We end up whispering metaphors just to stay sane. But maybe that's okay. Maybe you don't need to understand all the math to feel the math. Maybe you just lie back, let the numbers pass through you like stardust in a breeze, and accept this. You are a speck of consciousness riding a planet that circles a sun that lives in a galaxy. That is one of 2 trillion in a universe that may be infinite and also possibly an illusion. And somehow, despite all that, you still check your phone at 2 a.m. because you heard a weird noise in the kitchen. This is the paradox. You are small, and yet you're here to witness the bigness. You're made of atoms that were cooked in stars, part of the system, the story, the expansion. You're not outside of it. You're inside the vastness, living in it, thinking in it, wondering in it. So tonight, under these ancient photons, remember, you are made of the same matter as galaxies. You are a participant in the universe's long unfolding. You don't just look up at the stars. Part of you is still in them. Now let's ask something quietly unsettling. If the universe is expanding, and it is, what's going to happen to everything in it? Where is all this going? Because here's the thing. The universe isn't just coasting outward like a calm breath. It's accelerating. Every galaxy we're not gravitationally glued to is drifting away faster and faster over time. It's not just expansion, it's runaway expansion. This strange acceleration was discovered in the late 1990s by teams of astronomers studying distant supernova. They expected to find that the universe's growth was slowing down after the Big Bang. But no, the data screened something else. The universe is flying apart, and it's speeding up as it goes. So what's causing this? Enter the mysterious culprit, dark energy. It makes up roughly 68% of the universe, and we still don't know what it is. It's like the anti-gravity of the cosmos, gently pushing everything apart at faster and faster rates. It doesn't clump. It doesn't glow. It doesn't interact with matter the way we expect things to. But it's out there, everywhere, stretching the very fabric of space. And now the big question. How does it all end? That depends. There are several theories about the fate of the universe, and they all have poetic names with eerie implications. The Big Freeze is the frontrunner. If the expansion continues forever, galaxies will drift apart until their light no longer reaches us. Stars will burn out. Planets will freeze. Matter will decay. Eventually, only faint whispers of radiation will echo in an empty sky. The universe won't explode, it'll go quiet, cold, empty. Here's your mainstream science moment. In current cosmology, the Big Freeze is the most accepted future scenario. Based on measurements from the Hubble Space Telescope and Planck satellite, it fits with the accelerating expansion and the nature of dark energy, at least as far as we can tell from this speck of rock and dreams. But let's get weird. There's another theory called the Big Rip. This one says that dark energy might not just expand space, it might eventually become so powerful that it rips everything apart. First galaxy clusters, then galaxies, then solar systems, then planets, and finally atoms. Space would expand so fast that matter itself couldn't keep up. That's the cosmic equivalent of the universe, panicking and tearing its own pages out. Most physicists think the Big Rip is unlikely, but it's still on the table. And it makes for a spooky bedtime story. There's also the ancient idea of the Big Crunch, where gravity eventually wins and pulls everything back into a fiery finale. A reverse Big Bang, but recent observations show that expansion isn't slowing down, so the crunch has fallen out of favor. Still, in all these endings, one thing becomes clear. Time, as we know it, is temporary, not just for you. For everything, eventually. There may be no clocks left to tick, no stars to cast shadows, no minds to wonder what time even meant. But don't worry, that's in the far, far future. In your lifetime and many trillions more, there will still be stars, light, warmth, and cozy conversations about black holes and oiling galaxies. And here's the beautiful part. You live in a rare moment, when the night sky is still bright, when galaxies still fill the telescope, when we can still see the past. Future beings, if they exist, may see nothing at all. They may believe they're in a dark, lonely cosmos, unaware that it was once filled with dazzling stars and wild expansion. But you're lucky. You're here while the universe is still telling its story. So as you lie in bed with your hands folded like stars over your chest, feel this. You're not just inside the universe. You're in the golden age of knowing it, and that is a miracle worth whispering about. Let's imagine, just for a moment, that you could rise above it all. Above the earth, the stars, the galaxies up and out, until the entire observable universe is a faint glowing sphere behind you. What would you see next? Nothing. And yet, everything. Because outside that glowing sphere, there's still more universe. Possibly infinite space. Possibly other realms. Possibly nothingness so profound it defies the word. We've reached the edge of the observable universe. Yes, but not the edge of the universe itself. That edge, if it even exists, might be forever beyond our reach. This is where human imagination gets tired, or giddy, or both, because the truth is, the universe may have no edge at all, no center, no outside to look into. It's a strange loop curving in dimensions we can't touch, expanding into a space we don't understand, and doing all of this without asking for our permission or comprehension. And here's a comforting thought. Science doesn't pretend to have it all figured out. In fact, the more we discover, the more mystery we uncover. Every answer opens 10 new questions. Every telescope is also a mirror, showing us not just where we are, but how little we know. Here's your historical moment. In the 1920s, astronomer Edwin Hubble, the telescope guy, discovered that galaxies are moving away from us, and the farther they are, the faster they recede. That was the birth of modern cosmology. 100 years ago, people thought the universe was static and eternal. Today, we know it's expanding, dynamic, and filled with dark matter and energy we can't see. But here's your fringe theory to fall asleep to. Some physicists suggest that the entire universe might be a kind of simulation, a sophisticated projection created by laws we haven't cracked yet. Not necessarily with purpose or a programmer, but as a natural mathematical structure. The idea isn't science fiction anymore. It's a real discussion in academic circles. One day, you might wake up and find out that reality was just one beautifully rendered level of something even stranger. Now let's come back down, back to your body, your heartbeat, your thoughts, because the universe isn't just out there. It's inside you too. The iron in your blood was forged in the heart of a dying star. The oxygen you breathe comes from the gentle labor of ancient cyanobacteria. The calcium in your bones is as old as the Milky Way. You're not a guest in the cosmos. You're its expression. In the brief span of a single lifetime, you get to witness comets, eclipses, solar storms, and perhaps the northern lights. You get to hear whispers about quasars and wormholes, and wonder what's just beyond the edge of knowing. You get to feel, And maybe that's the best part of all this. Because in a cold, expanding universe, the warmth of consciousness, your own, quiet awareness is a rare and remarkable spark. It's fleeting. But it matters. So the next time you stare into a starry sky and feel small, remember this. You're made of the same things that shine. And you're here, now, awake. And that, dear explorer, is the real wonder. You're floating now, somewhere between galaxies. Far from home, far from sound. Out here, space feels less like distance and more like silence stretched taut. If you tried to scream, no one would hear it, not because they're ignoring you, but because there's literally no medium for your voice to travel through. It's not emptiness. It's a vacuum. A whispering nothingness that carries stars on its back. And even here, in this vast hush, the universe continues to expand. Faster and faster. Not into something, but into itself. That's the strange part. Space isn't spreading into empty space. It's creating new space as it goes. Like a loaf of raisin bread rising in the oven. The raisins, galaxies, drift apart, not because they're moving, but because the dough between them is growing. You're not watching objects fly. You're watching the stage stretch. But even that metaphor eventually fails. Because here's a weird twist. While galaxies are moving apart on large scales, gravity still holds smaller systems together. That's why the Milky Way hasn't flown apart like confetti. That's why you're not drifting through your bedroom walls right now. Expansion of the universe is only noticeable when you're looking across millions of light years. On that scale, it's like a calm, unending breath and inhale that never stops. Historically, this whole idea would have made ancient astronomers laugh or cry, or both. The geocentric universe? A fixed dome of stars? That's what we believed for most of human history. But now, we know that light from the farthest. Galaxies is redshifted, stretched like taffy as it struggles to reach us through growing space. That redshift is the fingerprint of cosmic expansion. But not everyone agrees on what it means. Here's the academic debate. Some physicists argue that we're in a flat universe, where expansion will go on forever, thinning out galaxies, until only black dwarfs remain. Others suggest that gravity might one day slow it all down, ending in a big crunch. Still others imagine a big rip, where expansion accelerates so much that even atoms are torn apart. Cheerful, right? And now, a bit of fringe flavor for your late-night thoughts. A few cosmologists are toying with the idea that what we perceive as expansion is an illusion created by changing constants, like if the speed of light or strength of gravity is subtly shifting over cosmic time. In that case, we're not expanding, we're evolving in perception. Wild, huh? So let's come back to where you are now. Still, quiet, breathing. The space between your thoughts stretches just like the space between galaxies. Sometimes, the best kind of understanding comes not in a rush of facts, but in a soft, echoing pause. A kind that lets wonder sneak in without needing permission. You're part of this grand expansion, you know. Not just physically, with your atoms and energy, but mentally, emotionally. Every time you learn something new or imagine something bigger than yourself, your inner universe expands too. So drift with it tonight. Let the cosmos widen around you as your breath deepens. No rush. Number. Edge. Just the slow, steady rhythm of a universe growing in every direction. And you're right at the heart of it. You find yourself drifting now, deeper still past the spiral arms of galaxies, beyond even the great galactic clusters. The stars have thinned out here. The space between galaxies stretches wider than imagination. It starts to feel like maybe there's nothing left. But then suddenly there is something. A great wall of galaxies. A structure so immense, so utterly beyond comprehension, it makes your spine tingle even lying here in bed. This isn't fiction. It's real. Astronomers call it the Hercules Corona Borealis Great Wall, and it's one of the largest known structures in the observable universe. It spans more than 10 billion light-years across. That's right, billion with a B. We didn't even exist when the light from its farthest edge began its journey toward us. It's not a wall. Like a fence, of course. It's a name for a kind of cosmic filament, a pattern of galaxies, strung together like beads in a vast, invisible web. There are more of them. The Sloan Great Wall, the Boat's Void, the Laniakea Supercluster. They form what's called the cosmic web, and it's exactly what it sounds like, a tangled, gossamer network of matter and dark matter stretching across the universe. What's in between those threads? Not much. Vast voids hundreds of millions of light-years wide, where there's almost nothing at all. No stars, no galaxies. Just a few lonely atoms, like dust in a desert. The scale of this web isn't just big, it's structured, which raises weird, dreamy questions. Why is the universe arranged like this? Why filaments and voids, and not some other shape? And here's where things get deliciously strange. Some physicists have noted how eerily similar the cosmic web looks to neural networks in a brain. Our brain, to be precise. Imagine zooming way out of the universe and seeing something that looks unsettlingly like a brain cell. Now imagine the universe is a brain, that galaxies are synapses, that black holes are memory cores, that your thoughts right now are part of a recursive pattern echoed in the structure of everything. Sounds like stoner talk, right? But here's the thing. Some serious researchers are exploring the idea of panpsychism, the notion that consciousness might be a fundamental feature of the universe woven into its very structure. Not your consciousness, not my dreams, but awareness in the way a forest is aware of sunlight or a river knows how to flow downhill. It's not about thinking. It's about responding. And if the universe is a brain or something like it, then its expansion, its webs, its stretching tendrils might be some form of processing. Like it's working something out. Cue the fringe theory of the night. Maybe the Big Bang wasn't the beginning of everything. Maybe it was the firing of a thought, and everything we are is just the echo of that original spark rippling through time. A thought 13.8 billion years in the making. But let's come back to your room, your soft blanket, your breathing. The universe can feel dizzying, yes, but you are not outside of it, peering in. You are inside it, breathing with it, part of the filament, the pulse, the dream. Maybe you're a neuron in the universal mind. Maybe you're just someone lying in bed trying to fall asleep. Either way, you belong here. And this vastness? It's not there to overwhelm you. It's there to remind you that mystery doesn't have to be scary, that it can be beautiful. Now let's get a little weird. Not aliens in crop circles weird, but what is the shape of everything weird? Because as big as the universe is, it still might have a shape. That's not just a poetic idea. It's a real scientific question. Close your eyes for a second and picture space. What do you see? A big black room dotted with stars? Maybe an endless grid stretching forever? Most of us imagine space as flat, like a cosmic map unrolling in every direction. But here's the mind-bending part. The universe may actually be curved. There are three main contenders. First, if the universe is flat, then parallel lines stay parallel forever, and space stretches on without bending. This is the favorite in most current models, supported by measurements of the cosmic microwave background, the faint afterglow of the Big Bang. It behaves more or less like it came from a flat universe, but then there's the possibility that the universe is closed, like the surface of a giant four-dimensional sphere. That would mean if you could travel far enough in one direction, you'd eventually end up right back where you started, like walking around the Earth. Or maybe the universe is open, curved like a saddle, where space is negatively curved and parallel. Lines drift apart. And here's where it gets trickier. No matter how hard we try, we can't measure the whole thing. We can only see the observable universe, the part of the cosmos close enough for its light to have reached us since the beginning of time. That's about 93 billion light years across, give or take. But what's beyond that? Nobody knows. The idea that the entire universe might be infinite is both thrilling and, frankly, exhausting. Imagine standing on the edge of a cliff, and the cliff just keeps going. No end, no wall. Just more cliff. That's what thinking about an infinite universe feels like. Let's take a breath. Historically, the idea of infinite space was terrifying. Ancient models of the cosmos were always finite. Bounded, closed. The firmament, the dome of stars, the crystalline spheres, they gave a sense of comfort, a sense of containment. But modern cosmology? It's like realizing your fishbowl doesn't have walls. It just keeps going. Here's a mainstream fact. For the night, current observations suggest that the universe is very close to flat, with only the tiniest margin for curvature. It's not conclusive, but it's the best we've got. And now for something fringe. There's a theory called topological lensing, which suggests that the universe could actually be finite, but wrapped around itself. So the same galaxies might appear multiple times in different locations in the sky, because light is looping through space like it's inside a hall of mirrors. Imagine walking through your neighborhood, turning a corner, and seeing yourself walk past the same house again, but from the other side. Even better, there's a hypothesis known as the toroidal universe. Yes, like a donut. In this model, the universe is finite, but has no boundaries, like the surface of a torus. You could keep flying through space forever and never hit a wall, just circle endlessly. Kind of like wandering through IKEA with no exits. But honestly, maybe the question isn't how big the universe is. Maybe it's how big your perception is willing to grow. Every time we look deeper, measure more precisely, build bigger telescopes, we're not just expanding what we know, we're stretching the very fabric of what it means to ask questions. And that's kind of beautiful. So wherever the edge of the universe is, if there even is one, you're already connected to it. Through photons that have traveled across billions of years. Through atoms that were forged in the cores of ancient stars. Through thoughts that stretch across time like constellations drawn in your sleep. So lie back and don't worry about reaching the edge. Let the universe come to you. You might be thinking, okay, so the universe is big. Really big. Possibly infinite. But what exactly is filling all that space? Is it just stars, galaxies, and lonely planets? Or is there something more? Let's talk about what's not so visible. Because as it turns out, most of the universe is made of stuff we can't see, or touch, or even fully understand. I'm talking about dark matter and dark energy, the two great mysteries that dominate our cosmos like invisible puppeteers. First up, dark matter. It doesn't glow, reflect, or absorb light, which means we can't see it directly. And yet, we know it's there because of how galaxies move. Galaxies spin too fast to be held together by the gravity of their visible matter alone. They should fly apart, but they don't. Something unseen is adding weight, keeping them intact. So scientists proposed dark matter. Invisible, massive particles that interact through gravity, but not light. Like cosmic scaffolding, it shapes the large-scale structure of the universe, guiding the formation of galaxies, galaxy clusters, and the cosmic web. Some estimates say dark matter makes up about 27% of the universe. You, me, the stars, and everything we can see? Just 5%. Let that sink in. Everything you've ever known, books, animals, oceans, cake, it's all built from the tiniest sliver of what exists. Now for the even weirder one, dark energy. In the late 1990s, astronomers discovered something bizarre: the expansion of the universe isn't slowing down, it's speeding up. That's like throwing a ball into the air and watching it accelerate instead of fall back down. To explain this cosmic acceleration, scientists invoked dark energy, an unknown force or property of space that pushes galaxies apart. It's not like regular energy. It doesn't come from stars or motion. It might be tied to the vacuum of space itself, an intrinsic pressure that grows as the universe expands. Dark energy is believed to make up about 68% of the total universe. That means almost 3/4 of the cosmos is driven by something we can't even begin to explain. And yet, here you are floating in your bed, soft blanket on your chest, breathing air made of atoms, thinking about things that outweigh everything you've ever seen. A fringe theory for tonight's dream. Some physicists wonder if dark energy is evidence that we're just one bubble in a much larger multiverse. A sort of cosmic foam where different universes expand and contract, each with its own laws of physics. Maybe our bubble has dark energy. Others might not. Some might have 3 dimensions. Others 7. And you thought your apartment was weird. Let's not get lost, though. Let's return to a grounded idea. We are mostly made of nothing. Even at the atomic level, most of what exists is space. The nucleus of an atom is tiny compared to its electron cloud. So when you tap your fingers together, you're really just pushing together clouds of probabilities. So maybe the universe isn't just vast outside of you, it's vast inside you too. The same laws that govern galaxies govern your heartbeat. The same mathematics that describes the expansion of space applies to the way sound moves through your room. And that's the secret. No one tells you in science class. You're not separate from the cosmos. You're a local expression of it. A pocket of matter and energy briefly arranged into thought. So when we ask how big the universe is, maybe we're really asking, how big are we, really? You right now are a doorway into the infinite. And that might just be the coziest thought of all. Let's take a quiet stroll into one of the most delicate, dizzying questions of them all. Where exactly is the edge of the universe? This is where your imagination might want to picture a giant wall in space. Maybe bricks, maybe lasers, maybe a cosmic "do not enter" sign guarded by sarcastic alien customs officers. But the real answer is, there is no wall, no order, no line to cross. Instead, the universe is expanding everywhere, not like a balloon being inflated into empty space, but like the fabric of space itself, stretching from within. Every galaxy, every cluster, every glowing speck is moving away from every other one. Not because they're zooming through space, but because space is being created between them. It's not that galaxies are traveling across a cosmic stage. The stage itself is growing wider. So when we say the edge of the universe, we're usually talking about the farthest distance that light has had time to reach us since the Big Bang. That's called the observable universe, about 93 billion light years across. Yes, even though the universe is only 13.8 billion years old, the observable size is far bigger. That's because the fabric of space has been expanding faster than the speed of light. Not in violation of physics, because space isn't a thing with mass. It can expand however it wants. Like a magician's sleeve that just keeps getting longer. Beyond the observable universe lies who knows what? Possibly more galaxies. Possibly infinite space. Or possibly nothing, a concept so slippery that even seasoned cosmologists get a bit glassy-eyed trying to define it. Here's a mainstream fact to ground us. The cosmic microwave background, the faint afterglow of the Big Bang, gives us a sort of snapshot of the oldest light in the universe. It's the baby photo of everything, stretched thin and cold across the sky. And from that picture, we can infer a lot. How old the universe is, how fast it's growing, and how it might end. Now, for the weird part. Some researchers believe we might live in a universe that loops back on itself, like the surface of a sphere. If that's true, you could, in theory, travel far enough in one direction and end up back where you started. Like cosmic Pac-Man. And here's where it gets beautifully abstract. If the universe has no edge, no center, and no fixed reference point, then everywhere is the center, including your pillow, including the cup of tea on your nightstand, including you. When ancient astronomers looked up and tried to make sense of the stars, they often assumed Earth was the center of everything. They were wrong in one way, but weirdly right in another. From your perspective, light has traveled billions of years to reach you. Stars have lived and died. Galaxies have danced and collided all, so their photons could flicker softly in your direction. So tonight, as you lie still and breathe slowly, you're not just gazing into space, you're the center of your own cosmic map. In every direction you look, stretches toward infinity. Kind of makes that ceiling you're staring at feel like a portal, doesn't it? So, if the universe has no edge, and if it's expanding everywhere at once, what does that mean for us? Let's go smaller again down to your living room, your bed, the curve of your breath in the dark. You might think the expansion of the universe wouldn't affect you. After all, your tea doesn't fly away from its cup every morning. Your socks aren't slowly drifting apart. And thank goodness, because finding matching ones is hard enough already. But here's the strange truth. The universe is expanding, even here. It's just that local forces like gravity, electromagnetism, and molecular bonds completely overpower the slow, gentle stretching of space at tiny scales. Galaxies stay together. Solar systems stay put. Your spoon stays in the drawer until you forget where you put it, and then it's quantumly lost. But zoom out, far out, to the spaces between galaxy clusters. That's where cosmic expansion has its way. Galaxies separated by millions of light years are drifting apart, not because they're moving, but because space itself is growing between them. And eventually, the expansion will pull everything so far apart that distant galaxies will vanish from view. Future civilizations, if they exist, might look up and see nothing. No galaxies, no clues, no cosmic history. Just a black sky dotted with the dying embers of their own stars. This future has a name: cosmic isolation. And while it sounds dramatic, it's not science fiction. It's a real prediction based on current models. The farther into the future we go, the more alone our patch of space becomes. Like being the last lighthouse in an ocean that once sparkled with thousands of others. Here's a historical nugget. Astronomer Edwin Hubble first noticed in the 1920s that distant galaxies were redshifted. That is, their light was stretched, shifted toward the red part of the spectrum. This was the first observational hint that the universe was expanding. And a fun fringe theory? Some speculative physicists have proposed that the universe might one day stop expanding and bounce back in on itself, causing a big crunch. Everything, all of it, collapsing back into a fiery origin point. Rewind the movie of time. Start again. But most evidence right now points toward eternal expansion. A slow fade into cold, thin emptiness. And yet, there's something oddly comforting about this. Because even though the universe will keep growing, even though it will eventually be dark and quiet, you are here now, listening, wondering, breathing. In a cosmos 93 billion light years wide, in a moment of time, so tiny it can't even be measured, you're experiencing it. That's not a small thing. That's not forgettable. And if you feel small in the face of it all, that's okay. It means you understand the scale of what we're floating in. But remember, even a tiny light in a vast dark sky still shines. Now, let's talk about the horizon. No, not the kind you see when the sun melts into the ocean, but the cosmic one, the observable universe. There's something beautifully frustrating about the fact that we'll never be able to see the whole universe. Not because our telescopes aren't strong enough, or because clouds keep getting in the way, but because the light from some regions simply hasn't had enough time to reach us. Picture this. The universe is 13.8 billion years old, but because space has been expanding while light has been traveling, the edge of our observable universe is not 13.8 billion light years away. It's more like 46.5 billion light years in every direction. That's the current estimate, anyway. Wild, isn't it? You're sitting on a tiny rock, spinning through space, in a pocket of reality, so enormous it takes light itself, the fastest thing in the cosmos, billions of years to get around. And yet, that's just the observable part. Beyond that, we simply don't know. There might be more universe, maybe infinitely more. Galaxies we'll never see, matter that will never meet us, stars whose light will never brush our skin. It's like standing on the shore of an ocean you know exists, but you're only allowed to look at 1 teaspoon of it. Some scientists propose that the universe could actually be infinite, no edge, no boundary, no wall at the end. Just more. More stars, more galaxies, more empty space. An endless quilt of possibilities stitched together by gravity, time, and dark energy. But here's the twist. Even if the universe is infinite, the part we can interact with, the observable bubble around us, is limited. We're like goldfish in a gently expanding bowl, watching the outer edge move farther and farther away. Historical moment for the curious. In 1964, scientists Arno Penzias and Robert Wilson discovered a faint hum of microwave radiation coming from all directions. At first, they thought it was interference from bird poop in their antenna. Turns out, they had accidentally stumbled upon the cosmic microwave background, the afterglow of the Big Bang, still whispering across the cosmos. That faint radiation forms the oldest light we can see, a kind of baby photo of the universe itself. But let's go weird for a second. Some fringe cosmologists believe that beyond our observable bubble, there might be other universes. A multiverse. Each with its own laws, constants, maybe even versions of you, some brushing their teeth, some made of plasma, and some who never forgot where they put their house keys. Of course, there's no evidence for this yet. But just thinking about it can make your scalp tingle a little, can't it? Now, back to your bed. You're lying there, still and warm, eyes half-lidded. And you are part of all this. The energy in your body, the electricity dancing in your brain, it's all part of the same universe that stretches beyond what any eye can see. And maybe that's the real point of scale. Not to feel small, but to recognize how much you belong. You're not just in the universe. You are the universe, thinking, wondering, drifting softly into sleep. The edge may be unreachable, but your presence here now is proof that the cosmos folds in on itself in ways we may never fully understand. So, let's zoom back in. You've heard of atoms, right? The tiny building blocks of matter, smaller than your thoughts, dancing in patterns so fast and precise they make your phone work and your heart beat. Well, here's a mind-bender. If the universe is expanding, and we're part of the universe, why aren't you expanding too? This is where gravity gets fussy. While the universe as a whole stretches like warm dough rising in the oven, smaller structures like galaxies, solar systems, and the molecules in your body are held together by forces strong enough to ignore the expansion. It's like blowing air into a balloon, but the glitter glued to the rubber stays put. Galaxies don't stretch, they swirl. Stars don't drift apart. They burn and pull. And yet, on the biggest scales imaginable, larger than clusters of galaxies, larger than your most existential thought, space does expand. It's not that galaxies are flying through space away from each other. It's that space itself is growing between them. Imagine ants on a balloon's surface. From their perspective, the distance between them increases. But they're not walking. The balloon is just getting bigger. This cosmic expansion was first theorized by Georges Lemaître, a Belgian priest and physicist who in the 1920s proposed that the universe began from a primeval atom. Sounds poetic, doesn't it? Later, Edwin Hubble confirmed the idea through observation. Distant galaxies appear redder, their light stretched by expansion. A phenomenon we now call redshift. Now for the fringe. Some physicists propose that this expansion may not be constant. It might be changing, accelerating, thanks to a force we still don't understand, dark energy. Whatever it is, it's pushing galaxies away from each other, faster and faster, like an invisible hand turning the volume dial on cosmic silence. But here's something weird to lull you deeper into sleep. There's a limit to how far we can ever interact with the universe. Not just because light takes time to travel, but because expansion itself might eventually outrun light. Galaxies we can see now could one day disappear beyond a cosmic event horizon, becoming forever unreachable. Not because they moved, but because the space between us stretched too quickly. You, lying there in your blanket cocoon, are tucked into a small, cozy slice of a universe that's always changing, always moving, and always expanding into what, exactly? That's the tricky part. Space doesn't expand into anything. There's no outer space into which the universe grows. Instead, the fabric of space itself grows from within, like bread rising from the inside out. There is no outside. Of the universe, not in the way we understand outsides. Your brain might rebel a bit here. That's okay. So does everyone else's, even physicists. And yet, right now, this stretching universe is holding you close. The photons from your bedside lamp are gliding through a cosmic ocean of expanding space, calmly bouncing off the page, the walls, your fingertips. It's all connected. Your pulse, the gravity holding the earth beneath you, the whisper of distant galaxies. Somewhere, 13 billion light years away, a galaxy is moving away from us, so quickly that its light will never reach us. And yet, it too has planets, stars, perhaps life, perhaps lullabies of its own. You'll never see it, but it's part of your universe. Just like dreams are part of your night. Let's stay out here a bit longer, floating in the vast, dark quilt of expanding space. Imagine this. A night sky untouched by light pollution. Somewhere remote, silent and cold. You look up, and the stars feel endless. But the thing is, you're only seeing a tiny fraction of pinprick on the veil. Even with the best telescopes, we can only see as far as light has had time to travel since the beginning. This gives us something called the observable universe sphere, about 93 billion light years across. That's right. Light has only had 13.8 billion years to travel. But because of the expansion of space itself, the edge of what we can observe has moved much farther out. It's like standing in the center of a vast ocean, watching distant ships disappear, not because they're too far away, but because the sea itself keeps getting bigger beneath them. But here's the kicker. The observable universe is not the whole universe. It's just the part we can see. Beyond that, no one knows. Could be more galaxies, infinite space, strange geometries, or something even stranger perhaps, nothing at all. Cosmologists propose several possibilities. 1. The universe is infinite, no edge, no boundary, just endless stars and dark matter as far as math can imagine. Another? It's finite, but unbounded, like the surface of a sphere. You could keep traveling forever and loop back around to where you started, without ever hitting a wall. A cosmic Pac-Man map, if you will. But wait, here's a fringe idea. Some scientists speculate we might be living in a multiverse. Our universe might just be one bubble in a sea of countless others, each with its own physics, dimensions, and rules. Imagine infinite versions of reality, some with no stars, others where gravity runs backwards, and maybe one where cats walk people. A bedtime thought for those who love infinite detours. And still, all we truly know is this one tiny universe. This one dot. This Earth. This fragile blue pebble orbiting a single sun in a sleepy corner of one galaxy dot your body. Yes, you made of particles that emerged from supernova, moving through time, breathing in air once touched by dinosaurs, is part of this whole unfathomable thing. That should feel overwhelming. And yet, it also feels gentle, like the universe itself is whispering, "Hey, thanks for noticing." Here's a bit of science for your pillow. The cosmic background radiation, the faint microwave, whisper from the birth of the universe, still hums in all directions. Discovered in 1965 by Penzias and Wilson, it's the ultimate baby photo of everything. It's like static on an old TV, except the static is 13.8 billion years old. The universe still softly echoing its first breath. And while we try to build bigger telescopes, better models, and smarter theories, there's still so much we'll never know. So much that's hidden behind the speed of light, or trapped in the math of curved space, or waiting quietly in galaxies too far to reach. But that's okay, because here, in this tiny moment of awareness, you get to wonder. You get to ask how big the universe is. And that act alone, wondering, is part of what makes you beautifully, cosmically human. Maybe it doesn't matter whether the universe is infinite or finite, flat or curved, a bubble or a brain. What matters is that you're here, and the story is still unfolding. And just like the stars above, your own curiosity has no real edge. Let's take a breath. Close your eyes for a moment, if you want, and try to picture the whole universe. Not just the stars you've seen, not just the galaxies in Hubble photos. All of it. Can't do it, right? And that's okay. Your brain wasn't built to grasp infinity, but it was built to try. And that's the wonder of it. Now, we've been talking about the size of the universe, but let's bring in another question. What does it mean for something to be big? Size, after all, is always relative. To a grain of sand, your shoe is a mountain. To the Earth, the sun is gigantic. And to a galaxy, well, even our sun is a mere speck dot, so maybe we need better metaphors. If the entire observable universe were scaled down to the size of Earth, the Milky Way galaxy would be a single leaf in the middle of the Sahara. And our entire solar system? Maybe a grain of pollen on that leaf. Now imagine, again, your body. The atoms in your hands. The oxygen in your lungs. Every cell inside you has more complexity than any galaxy, in some ways. You are a little walking universe, made of the same particles that spin in spiral arms and echo in microwave background radiation. In fact, if we talk about scale seriously, the universe is nested in layers of complexity. The small contains the large, and the large reflects the small. Think of the Planck length, the smallest possible measurement of space. Now imagine the size of the observable universe, and realize both are equally mysterious, even more mind-bending. According to some cosmological models, space may not be infinite, but curved in higher dimensions. That means our universe could be shaped like a 4D sphere or hypersphere, curled in on itself in a way we cannot picture. Walking forever in a straight line could eventually bring you back to where you started, even though you never turned. Time might behave the same way. Space might be warped around itself by gravity, mass, and motion. We don't experience that in our day-to-day lives, but it's happening every second. Let me give you one last twist. There's a theoretical edge to the visible universe, but no one knows what's beyond it. The photons from those regions haven't had time to reach us. But they're out there. Their stories, their galaxies, their stars, they're all still waiting to be seen. As if the universe is holding back a curtain, letting us peek only so far beyond. So, here's a thought to take into your dreams. The farther we look into the cosmos, the farther we look back in time. Because light takes time to travel. When you stare at a distant galaxy, you're seeing it not as it is, but as it was, billions of years ago. A kind of cosmic time machine, powered by photons and wonder. You've probably heard the saying, we are made of star stuff. And it's true. But also we are made of story. Every measurement, every metaphor, every star we name, and every equation we scribble, it's all part of the way we try to fit the infinite into our finite minds. You're doing it right now, just by listening. And that's enough. So here we are. The end of the trail, or at least, the edge of what we can currently see. But the universe doesn't end here. It just keeps going. Now imagine you're floating again. There's no floor beneath your feet, no ceiling above. Just a vast, silent ocean of space. You pass star systems drifting like lanterns, galaxies turning like windmills, and great dark voids that stretch for hundreds of millions of light years. In every direction, more stars, more silence. But then something strange happens. You come to what we call the cosmic horizon, the farthest distance from which light has had time to reach us since the Big Bang. About 46 billion light years in every direction. Beyond that, we don't know. Not because there's nothing there, but because it's still hidden. The light simply hasn't had enough time to cross the vastness and arrive. Which means the universe, as you know it, is still a work in progress. There could be entire regions of space out there with completely different physics, different particles, even different types of atoms. Entire realities, unreachable, expanding away from us faster than the speed of light. Here's something wild. Because of the expansion of space, some galaxies are moving away from us faster than light itself. Not because they're speeding through space, but because space itself is stretching, carrying them like leaves on a river current. And that means some parts of the universe are already forever beyond our reach. We'll never see them, not now, not ever. This isn't sci-fi. It's cosmology. The universe is like a balloon being blown up, and we're dots on its surface. As the balloon expands, the space between the dots increases not because we're moving, but because the balloon is. And the farther away something is, the faster it recedes. Now, this doesn't mean the universe is exploding from a central point. In fact, there is no center. Every point in space is moving away from every other point. To ask, where is the center of the universe, is like asking, where is the center of the surface of a sphere? It just doesn't make sense in our geometry. Let's go deeper. Theoretically, there could be an infinite number of other universes, all with different laws of physics. This idea, called the multiverse hypothesis, suggests that what we call the universe might just be one tiny bubble in a much larger foam of existence. But here's the thing, we can't test that. Not yet. Maybe not ever. And that's where science meets humility. It's okay to say, we don't know. In fact, that might be the most honest thing a scientist can say. It means we're still exploring, still dreaming, still building instruments to peer farther, dig deeper, and stretch the limits of human imagination. And you? Just by wondering, by thinking about these things, you're part of that mission. You're one neuron in the brain of a curious species, floating on a blue dot, looking out at the dark dot. So, how big is the universe, really? Big enough that we might never measure it, but also small enough to fit into your quiet thoughts as you drift to sleep tonight. And that's kind of beautiful. Now just breathe for a moment. You've been soaring through time, drifting across galaxies and brushing up against the edges of everything we've ever known. And now, it's time to come back. Back to your body. Back to your breath. Maybe the lights are off in your room. Maybe the world is finally still. All those vast distances, the billions of light years, the invisible fields, the strange physics, they all fade now, gently dissolving into the quiet of this single moment. Right here. Right now. And here's the funny thing. For all the cosmic scale, you're not lost in it. You're woven into it. You're not outside looking in. You're the universe, thinking about itself. Your breath is borrowed stardust. Your thoughts are echoes of ancient light. Your heartbeat? A quiet drum in the long rhythm of time. You don't need to figure it all out tonight. You don't need to hold on to the stars. Just know that curiosity, gentle, open, and wondering is its own kind of navigation. It will take you where you need to go. And sometimes, the most honest thing you can say is, I wonder. So let that be your lullaby tonight. A little wondering, a little drifting, a little piece of the universe, curled up under the covers. Sleep well, explorer. There are more stories to tell, and I'll be here when you're ready.